Yes, welcome to this video. Today we're going to share about being able or having that ability to, you know, come up with a solution to a cubic function. Solution to a cubic function. Of course, we want to use different methods to be able to solve our cubic function. So some of the methods that we have we're going to be looking at include graphical method, that is from -2 to +5, trigonometric method, Newton Raphson method, and factorization method. And I will say here now that whatever the method you're going to use, you must get the same answer. You must be able to get the same answer to the problem that you have. So to begin us off, I want us to begin with the graphical method, of solving the problem. So the graphical method of solving our problem, remember our problem is -3 x cubed plus 4x squared plus x minus 2 equal to 0. So using the graphical method, we have the graphical method there. So we begin with checking to ensure that we have at least 6 plotting points. As you can see on my screen, we have 6 plotting points. More than 6 plotting points are given there. So you come and write x values from -2, increasing by 1 step, to -1, -0, +1, 2, 3 to 5. So you will input the values of x cubed, then you multiply by a negative behind it. So as you can see, it is very clear that -2 multiplied 3 times, that you get -8. Multiply -8 by one negative number, then you're going to get +8. That happens also for -1, and for 0, 1, 2, 3, 4, 5 gives you -125, 4 gives you -64, and that continues like that. So second part of the equation, it talks of second term is 4x squared. So 4 multiplied by x squared. So x squared is -2 times -2, you get +4. +4 multiplied by 4, you get 16. And that happens for this one, that is -1 times -1, you get +1, times 4, you get 4. And 0 is for 0, and 4 is for 4, and that continues like that. Then you copy the values for x as shown. Finally, you have -2. So this part is the whole of your equation to say y is equals to, or f of x is equal to that. After that, you do the additions, and that is what you get. So you get 20, that gives you the plotting points. So you have the plotting points, that is for the equations. So next thing we're going to do is to look at the range of the values, and you go to the back page for the answers. So the next page will give us the answers of how that work was done. How that work was done. As you can see, the plotting points for x value, that's -2 for 20, -1 for 2, 0 for -2, that way, all the way to 5 for -22. As you can look at the plotting points, then you see that in here, in between -1 and 0, the value, the y has changed its sign, which means we have an answer in between these two values of x. And in between also these two values of x, the value of y changes from negative to positive. It means we have an answer in between these two values of x. Similarly, between 4 and 5, there is a change of the value, the sign of the y. Y values change from positive 2 to negative 22. That means there is a sudden change. So the value of the value of x which you are looking for will be found in between these two values of x, that is negative 4 and negative 5. And that is how we look at and we get our answers at it and get our answer. So from here, from the graph, we can see that the value of x1 is here, that is approximately 0.75, as you can do the counting here. Then the second value is x, that is 0.65. The third value is 4.15, as you can be able to see. So that gives us the answer for that. Now we move on to the second method. That is the trigonometric method. The trigonometric method is a method that we're going to use in this to help us to solve this problem. And what we do is we ensure that we rewrite the equation having a negative, the first coefficient changed to positive 1, and that is by multiplying through by a negative 1. If it were any other number, you make sure that you change that number to positive 1 by dividing by that number. So when you divide our equation above, this equation here, when you divide it by negative 1, the whole of it, the sign changes. It remains as it were, but the signs of its coefficients changes as shown. The second thing is to reduce the cubic polynomial, to remove the coefficient, that is to remove the term having x squared, and that is done by substituting x by y equal x is equals to y minus a over 3. In our case, a is negative 4. So when you put negative 4 there, you get x is equals to y plus 4 over 3. And when you do your substitutions, you get the value, you get to substitute like that, as you can see. So you use binomial expansion to be able to get those answers. And this is how it is done for the cubic term, for the term having the cubic power, multiplied by the first term and the second term. Then the second term is squared. And then you write the last part of it. And when you do the expansions, as you can see there, the y power 3 is here. If you expand, if you multiply through this one, you have 4y squared. If you multiply through this one, you have 16 over 3y. If you multiply through this one, you have 64 over 27. And when you come here on this term, you multiply 4, multiply by that, you have this. You multiply through here, you have 32 over 3 y. You multiply through here, you have 64 out of 9. 64 out of 9. Remember, this is 4 multiplied by 16, that is 64, but this is 3 squared, which gives you 9. All right, then you have y plus 4 over 3 multiplied by the negative, you get this, and then plus 2. So you see we have grouped them together in a way that you can easily add them downwards. When you do the additions, you have 0 here. You have actually excluded the term having the power 2. So you have y power 3 and y power 1 and then y power 0. And therefore you have your term given by that. Well, that is well said. That is, continue with our problem. Now we are ready to solve it. So using the trigonometric function, using the trigonometric method, this is how it is. That is how it looks like. And let y be equal to lambda cos theta. Then we have y cubed minus 19y over 3 minus 100 over 27. This one, if you substitute that, you get lambda cubed, cos cubed theta minus 19 lambda cos theta over 3 minus 110 over 7 equal to 0. At this point, I would like to say it is important to keep your work working with fractions. That is as opposed to working with decimal numbers. Fractions are better. You work with the fractions, then you resolve later. Thank you so much for that. So we are saying now we are comparing with 4 cos cubed theta minus 3 cos theta minus cos 3 theta. Just in case you are looking, you are asking yourself where we are getting this trigonometric identity, recall that De Moivre's theorem states that open brackets cos theta plus I sin theta close brackets power n equal to cos n theta plus I sin n theta. Letting n to be 3 gives us this, gives us that function that you have there. Then when you expand the left-hand side, using binomial expansion, you have that. When you expand using binomial expansion, you have that. This is what you have when you expand using binomial expansion. Maybe you have not seen it clearly. That is what you have. You write the Pascal coefficients at 1, 3, 3, 1. Then you reduce the powers of the first term up to 1. Then you increase the powers of the second term up to 3, from 0 up to 3. All right. Once you do that, you multiply through here, you multiply through here, you multiply through here, you multiply through there. And those are the answers you get. So let I squared be negative 1 and use this fundamental trigonometric identity there. All right. Once you have that, you have the values given as shown. Of course, we are replacing I squared is equals to 1. This value here will be 3 I squared, and this value here will be negative I. At that point, we collect the like terms. That means the real part and the imaginary part. This is the imaginary part, this is the imaginary part, and this is the imaginary part because next numbers. So this is a real part, so it comes here. This is a real part, so it comes here. Imaginary part comes there. Imaginary part comes there. Substitute using this trigonometric identity. This value here becomes cos, the one which had sine theta, sine squared theta. This value that had sine squared theta, it is the one that is here. When you expand, you get that. And this value that had cos squared theta, we will work on it. So that here it is, we have worked on it. And that's where you are. You have the real part on the left hand side and the imaginary part on the right hand side. Again, we have the imaginary part compared to that according to De Moivre's theorem. So we're going to continue. We equate the real part of the complex number. So when we equate the real part of the complex number, as you can be able to see there, when you have the real part of the complex number, that is 3 cos theta is equals to 4 cubed what? You have your identity as shown, because this cos 3 theta comes on this side and therefore it becomes negative, and that is what you wanted. Now, we were just working to show you where we were getting our value, but now if you could remember it, that's okay, there's no problem. We will just bring it directly here and compare. Now we want to compare as shown. Compare. As you see, if they are the same value, this is cos cubed theta, this is cos cubed theta, so we just get the coefficients and write them there, is equal to, if these two equations are equal, therefore the coefficients are supposed to be equal. So that's why we are picking the coefficients. This one, we write it here, divide by this one, we write it bottom. This one here, we write it there, and this value here, we write at the bottom. You see? So as you can see, we will relate the first two first, then later we will relate this one to be able to solve our problem. Let's begin with the first relation. At that, you already see that we are, while we relate, we cross multiply. When we cross multiply, that's what we get. Then we factorize. When we factorize, we have lambda outside, and first value of lambda is 0, or lambda squared is equals to 76 over 9. That means lambda is going to be 76 over 9, the square root of it. On the second relate the two terms. We want to relate this term, and we already have the value of lambda here. So what we are going to do is very simple. We are actually going to relate these two, and as we relate the two, we make cos 3 theta the subject of the formula, and that is what we get, cos, and obviously when you do the multiplication, we're going to get cos 3 theta is 0.64099. So we already have the value of cos theta, as you can be able to see. So value of cos theta is positive 0.664098. So we want to get the angle whose cos is that we should look for the cos inverse, and the cos inverse of that number is 48. So if you draw our unit circle, we realize that cos is always positive in the first quadrant and in the fourth quadrant. First and fourth quadrant. We have 3 theta is equals to that. So in the fourth quadrant is going to be this angle 360 less this angle. We get this angle 311.613177. All right. We also, because we only need 3 answers, and we must have the 3 answers. So the third answer is we are going to add 360 to the first angle. That is 48.386823. We are taking 6 decimal places because we want our answer with an accuracy of 5 decimal places. That is why we are getting our angles with a high degree of precision. So with that, we get 408.386823. So we need the value of theta, therefore we divide through by 3, and those are the angles that we get. We get 16.12894 and 103 and 136, as you can see. Remember, y is given by lambda cos theta. So for the 3 thetas, we're going to get the value of lambda, we got it. So we multiply the value of lambda with the first value of the angle, cos of that angle. Then we multiply this with the second value of the angle and the third value of the angle. And once we do that, we get the values of y, which are solutions in y. But remember that our question was asking us for the values of x. So we replace our values of x. Remember that y, we say x is equals to y plus 4 over 3. Recall this equation. That's what the one we are solving. So when we do that, we add 4 over 3 to the first answer. We add 4 over 3 to the second answer. The third answer, we also add 4 over 3. And that gives us those answers. And of course, that is where we end our video on trigonometry. New Newton Raphson method. The problem is the same. That is f of x is negative x cubed plus 4x squared plus x plus negative 2 or minus 2. So the first thing we do is to differentiate f of x with respect to x. That is negative 3 x squared plus 8x plus 1. Next thing is to decide the first root. That is, we decide x not equal to 1 because the graphical method has proved that there is a root between 0 and positive 1. Next is to write the Newton Raphson formula. That is, a beta root is the previous root minus f of x plus divided by f prime x. That is what we do. So we write our x minus negative x cubed plus 4x squared plus x minus 2 divided by f negative 3 x squared plus 8x plus 1. So we replace, or we call it substitute, the value of x. We say that x is 1. So replacing the value of x, we have the value as shown. So when we do the calculation, we get 0.66666. You need to, when you need 5 decimal places accuracy, you write up to 7 decimal places. The second iteration is as shown. You see, replace the values of x, x1, and that is 666, like that. So that is how you replace, and that is the value you get for the second iteration. So you get 0.637037. We go to the third iteration. In the third iteration, we write the answers for the second iteration as our values of x. And when we substitute, that is the answer we get. And as we move along, we compare our answers for x with the previous iteration values. So we see that these two answers, x2 and x3, only compare up to 2 decimal places. So that means we can still do more iterations. Placing the third value, as you can see. So that is the value, the answer we get once we do our fourth iteration. Now, when we look at the third and the fourth iteration, we recognize that the fourth and the third are correct, or they agree up to 5 decimal places. Therefore, we pick our answer for the beta root as 0.63667 up to 5 decimal places. So remainder theorem is our fourth method, which will assist us. So with the remainder theorem, we use it when we have at least one of the roots. So one of the roots we have found using Newton Raphson. So we use remainder theorem to get the others. All right. If factorization, if f of x, if the value of x is 0.63667, therefore x subtract 0.63667 is a factor of our main function. So when we divide, that is how division is done. But this one can be rewritten as that. We can rewrite it as the factor outside, then the number being divided inside, and we perform the long division. We perform, first thing we do, we ask ourselves, what can we multiply by x? What can we multiply by x to be able to, what can we multiply by x to be able to get x cubed? Negative x cubed. So what we can multiply by x to get negative x cubed is negative x squared. So negative x squared, we write it here first. We write negative x squared here first. Then this negative x squared, once we have written it there, we multiply this negative x by this x to get negative x cubed. Again, we multiply negative x by this value and we get the sign changes because you've multiplied negative by a negative, the sign changes to that, x squared. So at this point we subtract. When we subtract on the left hand side, it disappears. When we subtract at this point, we say 4 subtract this value, we get 3.36333. That is up to 5 decimal places. Remember class, it is up to 5 decimal places. So we need a more accurate answer, and so we need to do the due diligence. At this point, we drop our value of x down. Remember, the values of x keep decreasing from the highest power to the lower power to the least power. And if it were not there, then we would have put 0 x squared or 0 x. All right, they must be reducing inside here. At that point, we ask ourselves, what will we multiply with x to get this value? What will we multiply by x to get this value here? And at the same time, we realize we only multiply this value in terms of x. So that is 3.3633x. We multiply that one with x, then we get this answer. So that is the one we write here. So this multiplied by this, that is 3.36 multiplied by negative 0.63, we get 2.1 in the negative of that answer. That is the value we get here. Again, we subtract on the left-hand side. We subtract on the left-hand side here. When we subtract x less this, so it will be minus minus, x minus minus 2. When we do that, we get positive answer, which will be the addition of this. Then we drop our negative 2 on this side. Negative 2 on this side. So we ask ourselves, what will we multiply by this to be able to get x, to be able to get this? Again, we multiply the same number. That is 3.133. So we multiply that by this, we get this answer. We multiply this value by this value, we get negative 2. And again, now we subtract. Subtracting on the left-hand side, we get 0, and on the right side, we get 0. And therefore, the resulting quadratic is given to us as this answer at the top. So that is our answer. And our answer is a quadratic equation which can be solved using the formula method. Of course, we have other methods of solving, but we cannot use them here because the most accurate, the one that will give us the best answer in this case, because we are dealing with the decimal numbers, is the quadratic method or the quadratic formula method. Once we are using it, we must identify our A, we must identify our B and our C. And as you can see, we put the values there, and that is how we go to get the answers. So as you can see, we do that until we get our answers. So this is our answer, and x2 gives us the value for first answer is negative 0.76155 or 4.1288. And that brings us to the end of that presentation. As you can see, using the three methods, we have been able to get the same answer for the same function.